So thank you everyone for joining me on this program. Welcome once again. Today, before we commence this program of question and answer session, I would like to speak about the National Space Day, which is going to be celebrated on 23rd August this year, the very first National Space Day. As all of you are aware that the Chandrayaan-3 made a historic landing on the southern side of the moon on 23rd August 2023. So this is the first year anniversary of that event, and celebrations are being held all across the country in educational institutions, scientific institutions, as well as in the public places supported by ISRO and other departments and ministries of Government of India. I make it an opportunity to request each one of you to take the message of this Chandrayaan-3 historic landing and announcement of the National Space Day by our Honorable Prime Minister to every nook and corner of this country. Because we see this event is definitely an inspirational event for all of us, which created history. It showcased also our technological prowess in designing, developing Chandrayaan class of spacecraft and achieve soft landing on the moon. And definitely it's not just the soft landing, we were able to accomplish all the experiments, conduct all the experiments and obtain valuable amount of information. And with that, we have a long-term plan announced recently, which include continued mission to moon, Gaganyaan mission to its fruition, and taking human beings to have continued access to space with the building of space station, Bharatiya Antarikshya Station, ultimately taking an Indian to the surface of the moon. Let all of this happen in the Amrit Kal. So let us move over to the questions that you have already posted in various social media platform of ISRO. We have collected all the questions. They are in hundreds of them, so we won't be able to cover all those questions in 1 hour time. But then I have scanned through many of those questions, and I would like to take some of those very interesting questions and also some of them that are going live today that you are posting right now. So let me start with the first question. Mr. Shresh Singh asked me the question that why haven't humans not visited moon from such a long time? Whereas back in time during the space war, there were so many missions. Of course, the mission to moon was during the Cold War era when United States of America and Russia was trying to have supremacy and demonstrate their capability in sending human beings to moon. But that created such an interesting but very competitive, fierce competition among these nations to create who will be the very first. But then what happened afterwards is that we turned out that this mission happened to be very, very costly. For any nation to sustain this program for long years is not that easy. So after having accomplished the first human landing, United States of America continued the mission for some more time, and many human beings have gone to the moon and brought a lot of scientific outcome. But then we realized the potential of such an experiment. Converting that into a scientific outcome and also turn it into some commercial activity was not easy. That's why that interest came down. Later, the focus was on human access to space, like International Space Station, Skylab, and Mir space stations that were all built in the later years, and they continued microgravity and other space research activity through those platforms. So there is a renewed interest now to build capability to go to moon, create moon platforms, moon orbital stations, and use moon as a platform for continued access beyond moon. This change happened because of a very important reason, that access of human beings to space is now possible because the launch cost has come down. The technology has progressed. The amount of money that we need to spend mass or payload mass to space has now substantially reduced because of reusability, better manufacturing capability and technology that are available. And also the computational software electronic capability also improved, making it much more reliable. So the risk associated with such missions are much lesser in my opinion. So that's why there is a renewed interest, and of course the scientific outcome out of it could also be sustainable. Nations are able to look at it in a commercial manner, private companies are interested. That's why there is a renewed interest. So let me go to the next question. Mr. Kool speaks about space telescopes are key instruments to observe and to know more about space. Can ISRO send any space telescope for research? Of course, we have already sent some of them in space. Our telescope, especially the scientific observations, are already up there. The AstroSat hosts a UV telescope which is made use for observing deep space and then make some substantial findings. And we will continue to send our observational platforms in various forms. Essentially, telescopes are optical observatories, instruments that are part of many of our scientific missions as well as Earth observation missions. Here is one question from Arabelle Loves. I think it's Jagruti. Asked this question in one of our textbooks. It is mentioned that hydrogen is the fuel of the future. So, it's being used in rockets, and if not, why? Oh, great. Of course, hydrogen is a fuel of the future. This being talked about for us now in ground applications, but rocket people have been using hydrogen for so many decades. Even the very first rocket that went to moon used hydrogen as a fuel. So, we have cryogenic technology where liquid hydrogen and liquid oxygen is used to create water as outcome and then produce thrust. And in rocket propulsion technology, chemical rocket propulsion, use of hydrogen and oxygen is considered as one of the most efficient propulsion system. The cryogenic propulsion system, which gives almost 450 second ISP, the specific impulse, that is the thrust per unit mass flow of the propellants, and no other fuel combination can give this. But today, hydrogen is being talked about as the fuel of the future, not for rockets alone, but for mobility, for use in cars, aircrafts, power generation at home, and many other day-to-day applications. And creating hydrogen at very low cost is the target of research in many places. Hope that will come soon. And the challenge today is to produce per kilogram hydrogen at a cost something like 100 rupees or lower. So, this comes to be one of the biggest challenge, and a lot of research is happening all across the world. So, there are also some question from one of the friend asking why this program is on at 6 o'clock evening on Saturdays, why not on a working day? Of course, for students who are there in schools or colleges, this may be a better option, but then we consider that there are much more interest, and it could be much better viewed at the comfort of your home, not at the schools. And for us also, we are very busy on weekdays. So, this I found that on a Saturday must be a better option than on a weekday to involve all of you for this program. Okay, there is a question from Mr. Minerva Malayalam. Okay, so the question is on whether ISRO will ever become like NASA. Can India be very prominent in space activity? And how do you generate more curiosity and interest in youth in space, in science for India? Of course, let us not compare India, the ISRO with the NASA. I think that is not needed. Each space agency works for the goals that it set for itself, what it really wants to accomplish for the nation. And ISRO targets or plan what it need to achieve in for the country, for its civilian and other users, and within the resources that the country can put forth for itself. So, there is no need of any comparison. And for the curiosity and interest that you are talking about, that is precisely I started talking in the beginning about the Chandrayaan-3 and the interest that it has created, the space day that we are celebrating, bringing all of you on board on such programs like asking questions and the answers, and many other outreach programs that ISRO and other organizations across the country make it available to you to kindle that interest in space, for you to become interested in science, technology, and make that domain as a career in later years. Mr. Pras asked, when will ISRO take people to space? Yeah, that is very much in our agenda. The Gaganyaan program is the program that will take human beings to space using our craft, our rocket, and that will happen very soon. We are working on the Gaganyaan program, but a lot of work need to be done. We have to make our rocket much more safer, called human rating. We have to develop the human capsule, the crew escape system, and conduct test missions. And one which happened recently, and we will be continuing to have it, a launch of an unmanned crew vehicle first, followed by the manned mission or the crewed mission that will happen soon. So, we are hoping that next year end, we should be able to do the crewed mission taking human beings to space, but that will not be the end. We will continue that mission taking human beings up to moon soon, maybe not before the end of this another 25 years. Okay, there is a question on Chandrayaan-4. I think people are reading, listening to those articles on Chandrayaan-4, and they are very curious to know how Chandrayaan-4 will get assembled in space. And this question is asked by Mr. Bien Singh Thaliwal. Okay, good. I think you are very keen to understand how you build Chandrayaan-4. Chandrayaan-3, of course, possibly you would have already understood how it goes to from the Earth orbit to Moon orbit, slowly, progressively raising it orbit and finally reaching the Moon. But for Chandrayaan-4, there is a huge challenge. We not only have to go and land on the Moon, collect the sample, take off from the surface of the Moon like a rocket, go to the orbit of Moon, raise its orbit to reach Earth, not only to reach Earth, but it has to finally land on Earth. Landing on Earth is much more difficult and equally challenging than landing on the Moon surface, because there is no atmosphere on Moon, but on Earth there is an atmosphere and we need to overcome the atmospheric drag and heat, etc. So, it will be a complex re-entry process, but more than that, we need to have different elements of the Chandrayaan-4 that need to be connected, assembled in orbit. When human beings went to Moon for the first time in the US vehicle, they had to do the similar exercise of docking and reconnecting in orbit. And also on Moon, they have to go down and come back and dock to the mother craft at the orbit of the Moon. Similar process need to be followed for Chandrayaan-4, even when you want to collect some samples from the surface of the Moon. So, that technology related to docking, connection, disconnection and reconnection will definitely be part of Chandrayaan-4 mission. Okay, there is some technical question from Prithviraj Roy. He asked, how is the cooling system for spacecrafts work and how they are designed? Spacecrafts are in space. Space is a very, very difficult environment. If you look at sun, one side of you will become very, very hot. The temperature can rise to something like 200 degree, but just your backside can get cooled to very low temperature, because deep space is at a very low temperature, typically 4 Kelvin. So, when you see such contrasting issues that in space, but on Earth you do not see that, because on Earth the temperature or the heat comes out of various reasons, because every object around you radiate and there is air around you and there is a diffused heating that is taking place, and this makes the environment much more comfortable and uniform across you. But when you go to space, it is not the case. So, satellites which are looking at in space, in orbit, which are the side which is looking at sun, need to reject sun by creating surfaces which are very reflective, they do not allow heat to come in, and on the other side of it you need to make sure that it does not get cooled too much. But there is always heat generation happening inside satellite, like electronic packages functioning and other systems functioning. That heat need to be pumped out. So, there are heat pipes and radiators, and such surfaces are created on appropriate surface of satellite. So, there is sometimes you also put heaters where the temperature go very, very low. So, they put heaters especially on gas and liquid lines, so as to keep it warm whenever engines and thrusters need to function, and this is monitored by the computer, and they switch on and switch off appropriate times to make sure the temperature of the satellite does not go down. So, there is a combination of heat rejection and heating by appropriate orientation of the satellite in orbit. This is done very, very intelligently by the computer on board to keep the satellite at working condition throughout. It is a very critical design condition for satellite. So, all of you can learn it a little later. So, let me continue, look at some of the questions online. If there are any useful things that appear on this question, I will look at it. Okay, there are questions about in ISRO's key priorities and upcoming missions. So, I will advise you to look at our website and then learn about it instead of spending my time on speaking about all the programs. In this question and answer session, I will more dedicate on specific questions. Okay, there is a question from Tiasa sir. The question is that, are there any opportunities for students to contribute to research projects at ISRO or to collaborate with ISRO? Very good. If you are ready with a very good idea, we will be happy to collaborate and work with you. But being a student, my advice is that an idea that you have possibly won't find merit in a formal discussion with ISRO, because we deal with an advanced scientific topic, research topic. Possibly in student level, such an idea may not be there. And if you really spot a bright idea, we will be very happy to work with you. But generally, we collaborate with institutions, and especially academic institutions, industrial institutions, and work with those learned people as well as students in those institutions. So, many a times that will be a better way of connecting rather than individual level student connecting to ISRO. Possibly your academic institution where you are studying can talk to ISRO concerned people, and then the idea or the proposal of the project can be discussed, and we have mechanisms to fund it, especially with institutions. We have a program called Respond. We deal with such specific research topics which could be of interest, and if you have a better idea, definitely we will be very happy whether if it has any link with what we are doing today. Here is a question Mr. Jenny is asking. There are so many times ISRO has achieved milestones, many other agencies have not achieved, and where others have failed, you have achieved, they say. And that is a special part of ISRO that makes it possible. Of course, I won't claim that we are always successful. We have had enough of our share of failure. I think all those failures are behind us, but very important to look at continuously on failures and understand why there were some failures. Of course, it is very important to speak about failures. We had mission failure in some of our launches in the past. Some of the development launches of launch vehicles definitely did fail, like the first launch of the PSLV failed, the first launch of SSLV failed. We couldn't land soft land on the moon with the Chandrayaan-3. I think they were all realities. And when a failure occurs, we have a very solid mechanism within the organization to understand and go through the analysis of the failure and pinpoint the reason why which it failed. And we take a lot of actions and effort to how to mitigate those failures. So, as a space agency, I can tell you that this is a very unforgiving task of designing space systems, rockets and satellites and missions. Anytime it can fail, and there is no conditions of that failure will never happen, that can never be told. Precisely, it is because of this reason that the testing of any space system is not 100% possible in the ground condition. They need to actually fly, and when the very first flight is the actual flight, and there are no test flights possible in the fullest extent. So, the conditions in missions are always much more gruesome than that you actually do in ground. So, this is one of the reasons that failures can happen, but then with the time, with experience, you engineer systems in very skeptical way. You always ask this question, how it can fail, and we mitigate those failures by appropriate design activities. And this is a nature of our work. Possibly we are better off, and I think the Indian ingenuity definitely must be there behind our successes. I am very sure about it. Okay, there is an announcement of the Gaganyatris today that who are going to fly in the Axiom mission to International Space Station with NASA, the joint ISRO-NASA mission. And there is a question from Mr. Kiran Veera. He is asking what these astronauts, when they go up there, Gaganyatris go up there, they will do, what type of experiments they will do. The objective of this mission is not just the experiments alone. The process of going to International Space Station itself gives you so much of learning. One of our astronauts is going to be trained in the whole ground process of preparation of a Gaganyatri to go there, and that itself will tell us how you should prepare your Gaganyatris for Gaganyaan mission. And after that, when they really go through the flight experience and looking at the journey, the craft, the way in which they conduct the whole mission, and ultimately getting into an International Space Station of that class and working with an international crew who are already up there, will really give them the type of knowledge and skill which I believe they will tell back to us and to make us ready for our mission. Then coming to the specific experiments, we have already planned 5 different experiments. Some of them are originated in India, and we will be taking those experiments on board ISS, and some of the international experiments we will be joint partners to participate in those experiments. The prime astronaut crew which will go along with the mission will be the mission pilot, which will give him an exposure on how to conduct the mission itself. So, these are the type of specific instruments. At this moment, I will not be giving details of those specific instruments which are currently in discussion development level. Okay, let me look still at the screen where there are more questions or interesting questions. There are issues like questions like reusable thrusters. Is there any missions there to inspire students like Chandrayaan-3? Of course, there are students missions which are going to be much more interesting. You heard about Chandrayaan-4. We are talking about going to Venus. We are preparing ourselves to look at exosolar planets. We have the Gaganyaan program. I think all of this will become very exciting for all of you. I am very sure about it. So, let me continue. Why is ISRO far behind making of reusable rockets than other space agencies like SpaceX and Blue Origin? This question is asked by an undefined science. Okay, good. I think your name also says that we are not making reusable rockets, but I am very sorry that we are making reusable rockets. We have our reusable rockets are still in the development phase. You would have seen the landing of the RLV LEX recently. The third landing attempt was also successful. This is one of the precursor for an orbital reusable landing vehicle, which is more a winged reusable rocket. But meantime, we are also working on vertical landing, throttleable, propulsive assisted landing concepts like what you talked about SpaceX and Blue Origin. But this idea we had, but one of the deficiency of our capability was an engine, a liquid engine which can be throttled to very low level. This development was taking time, and one of the current engine which we have tested to a throttling capability. Now we can do a demonstration mission, but demonstration is not enough. We should actually make a full scale vertical landing vehicle, and this concept is now going to be incorporated into our next generation launch vehicle called NGLV, where we are putting a new engine, locksmith engine, and that engine will be designed with a throttling capability to go as much as 40% of its full thrust, and with that we should be in a position to make a vertical landing soon. All the technology elements meant for such a landing capability do exist in ISRO. It's a question of development time and maturing it to make it to a possibility. Definitely you wait for it, it will definitely happen. Okay, there is a question from Mr. Aparna Boral. Can a life science doctorate work in ISRO? If yes, what is the procedure of application? So, I believe that you are a PhD holder in the domains of life sciences. Definitely we will be in a position to take new recruits in that domain. Right now we do not have in ISRO. With the human spaceflight program now getting priority, it also being on a sustained manner when we are conducting, we have to develop those competencies and capabilities to look at bioastronautics, human physiology and related topics, and it is important for us to create such a pool of scientists who work in this in a continuous manner, and we will be looking at such expertise in the future. Definitely we should look for your expertise and skill, but what I will request you is that we have a live register for PhD holders in our ISRO website. You can register there and be available, and we will look at it whenever we are in need of and ready for advertising our post when it is open. Okay, there is a question from Mr. Worldwide Cyclone Tracking. Okay, great, it must be your handle, and the question is that is ISRO thinking of a manned mission to moon? Of course, we are talking about it now. We are envisioning such a thing possibility by 2040, but to make it happen there are many steps to cross. One of them is to go to moon and come back, that is planned in Chandrayaan 4. We need to increase our launch vehicle capability to a high level, typically something like 100 tons and beyond. That is envisioned through development of NGLV, the Surya vehicle, which we have already announced. Then we need to develop capability of human spaceflight, which is part of the Gaganyaan. So, when these three things come together, we should be in a position to graduate ourselves to the capability to have human going to moon and land on the moon and come back safely by 2040. Okay, there is in view of the natural disasters that are happening all across the nation, the floods and other issues, there is a question asked by friend Mr. Tushar. He says why we are not in a position to track people who are trapped in debris from space. Of course, the possibility exists, but then it is a very challenging technologically. When you look from space, typically 400, 500 kilometers away, you are looking at some signal, and that signal has to come through either an optical or radar or any other electromagnetic media, and it must be strong enough to be picked by the sensors on the satellite. Without that you can't do. Suppose you look at a radar method which can penetrate, it can penetrate to certain extent, but not to depths where there are debris and boulders and things like that are available. So, there are limitations of space-based sensors to locate objects which are deep buried under debris, which is currently an issue. There are many things which Earth space-based observation cannot observe. I think all of you know that deep under the ground what is available you cannot detect, but of course certain depth of penetration is always possible by radar signals. But then you cannot also find out underground channels, you cannot find out petroleum deposits and deep mineral deposits, but these are traced out by other signatures which are available on the surface, not by directly looking at those observations. So, of course, we should be aware of the limitations of observations that are posed by Earth observation systems. Okay, there is a question from Mr. Seema Rani. She asked, can I become a scientist by getting education through Hindi medium? Definitely, yeah, there is no doubt about it. The medium of learning is not a deficiency at all. It's a question of your intelligence and your ability to understand the subject. In your schooling, for example, for me, I also did not study in English in my schooling time. And after that, I was able to understand English and then took up science and engineering. And it helped me to understand it with a little bit of difficulty because you are learning a new language. Possibly the global literature of science and engineering and science could be mostly in English, but I am seeing that it is also going to be available in many other languages in India. Definitely studying in any language should not be a deficiency at all. I think you keep your mind and focused on it, I think you should be in a position to do great things even if you learn in Hindi. I think that should never be a deficiency. Okay, there is a question from Mr. The name is not very clear. Is asking, when will ISRO make big rockets like Falcon? In your definition, I think the big rocket is Falcon. Then I can tell you that we have a rocket called LVM-3, which is almost similar to the Falcon. It is almost similar, but it may be little deficient in terms of payload capacity. Our payload capacity for low Earth orbit is around 9 tons or 10 tons. And SpaceX Falcon 9 may give you something like 12 tons or maybe 13, 14 tons. So, it is not that different. So, our rockets are as powerful as capable of Falcon 9, but they have a bigger rocket called the Falcon Heavy, and other new versions are coming up. We are also working on newer, heavier versions of the rocket, and I am very sure India will be in a position to talk about going to moon. That will be in hundreds of tons, not very small numbers. Okay, let us continue with the questions available. The question, one of them, Mr. Shamuk Kumar asked is, what are the potential alternative energy sources for satellites that ISRO is planning to explore in the next few years? Energy source for the satellite comes from primarily the sun, the solar energy. That is the primary energy. There is always a propulsion system on board basically for attitude control or orbital control or going from Earth to moon or etc. They are generally provided by chemical propulsion. But we can talk about electric propulsion, solar electric propulsion. You can also provide using nuclear energy. Suppose there is a small reactor on board, using a gas like hydrogen, you can produce thrust, and nuclear reactor also can function in satellites. So, these are the some typical propulsion devices. There are many other technologies they talked about. It is by collecting hydrogen ions from the surface, from the space, and then energizing them. And there are antimatter propulsion and many other technologies that are being talked about, but not in practical terms at this moment. So, that is a point about satellite propulsion. Okay, there is a question from Shubha. She asked, I believe use of GIS in ISRO and the qualification required to get a GIS based job in ISRO. Okay, you are interested to learn remote sensing, image processing. GIS is Geographical Information System, and it is precisely the technology that we use. Once you get an image collected from satellite data, it is to be processed, and the processing requires a lot of understanding of the space and time, and correct understanding of the spectral and temporal variations in that, and finally produce some useful output out of those observations. And this is being taught in such courses, and we take a lot of such people in ISRO. We have a center called National Remote Sensing Center at Hyderabad, which is specialized in making use of satellite data and processing. We also have a center at Ahmedabad Space Application Center, which works on the technologies and algorithms for GIS data processing, and many application centers where the outcome of this is being put into use at various state centers. So, there is a possibility once you get graduated, postgraduate and doctoral degree holder in GIS sciences, definitely you will have an opportunity to get in an appropriate call for that comes. Let me continue with the questions on board. How are the material chosen based on the requirements? Mr. Kiran asks. It's a current online question. To balance between strength and stiffness as well as from thermal capabilities. Rockets and satellites are made of very advanced materials, and the materials are chosen for a function, and their strength is important, the stiffness is important, thermal capability is important, but all of them are not important at any given point in time. It depends on the applications. For example, if you are looking at a motor, rocket solid motor case, strength is important. Its thermal strength is not important because it will never reach that temperature. But some part of the rocket will reach very extremely high temperature. There we will not use steel, we will use carbon composite. And where the frequency is important, we will use a high stiffness material and not a high strength material. And if you have to handle pressure, then we will use a composite pressure vessel, not an aluminum based system. If you have to make a structure, we will make it out of aluminum because aluminum is much more strength and stiffness is reasonably high compared to many other materials. And manufacturing ability, that is also an important issue. Welding capability, especially pressure vessels, you have to use only weldable alloys and non-weldable alloys. So, fatigue capability, and there are many features that are required for materials to be used at specific applications. Okay, here is a question from Mr. Satyam. He asked, is the design of Bharati Antarisha Station complete and will be the first module launched? Bharati Antarisha Station is a station that we are planning to build by 2028 onwards up to 2035. This is going to be an Indian space station, and this space station will be capable of conducting long-term experiments in space. And the first module we are planning to launch by 2028 and complete the assembly of 5 modules to make it fully operational for human habitat by 2035. And I can tell you the design is currently progressing. The initial configuration design has been completed. What is the architecture of the Bharati Antarisha Station is fully completed, and we are going for approval to the government for allowing us to build the first station and go for launch in 2028. Mr. Jagruti Bodh asked this question. What should be the required educational path for a person to become a space scientist, an astrophysicist, and to get a job in ISRO? Congratulations, and if you are very keen on becoming an astrophysicist, my suggestion is the following. You need to be a graduate in science, especially in the domain of physics. So, first go through your school education. Suppose you are a student, be a good student in science, take your science education along, could be a graduate in physics, especially because it helps you to divert to an astrophysics stream. And there are many good courses and universities that offer these courses in state universities as well as national universities, and research capability in various science organizations across the country, specifically ISRS, as well as ISRO's laboratories at PRL, at VSSC, or even at URAO Satellite Center. There are astrophysics courses being conducted at other science institutions as well. And there are top-end astrophysics laboratories globally as well. So, you should try for all of them. We can do a graduate level course, a post-graduation, a doctorate in astrophysics, possibly could get job in ISRO or even at reputed university if you do fairly well. Okay. So, there is a question asked from Ayush. He asked a question, which could be the next satellite launch vehicle of ISRO? This I already answered. The last launch vehicle we developed is SSLV. Then after that we developed a vehicle called test vehicle. And now the next rocket that we are already on is called NGLV Surya. This is a next version of our vehicle which will have payload capability of typically 30 tons to low Earth orbit, or it could be around 10 to 15 tons to GEO orbit, and then it can be scaled up to 70 tons to low Earth orbit. So, this is our goal. So, this is a rocket which will take us human beings to moon, but meantime we are building it in building blocks level, so that initially it will build our space station, take human beings to space station, and also do other commercial missions, but it will scale up to do our manned mission to moon as well. So, there is an interesting question, Mr. Thunderbolt. Oh, he is asking this question. In future, can we use biogas as a propellant? It is eco-friendly. Of course, biogas can be used as a rocket fuel, And you know what essentially is this natural gases contains is methane. But it is not pure methane, it will contain other higher molecular elements as well. So, these aromatics are problem for rockets. So, we need to purify it to certain extent that the methane content is reasonably very high, so that the while it is in combustion, the soot formation, which is you see typically when you see in a cooking time there is a soot formation. The soot is not a good thing for rocket engines, because the very thin channels where this liquid flow, the soot will deposit and will block it over a period of time. So, we can't use these gases in gaseous form, they need to be compressed, they need to be liquefied, and once you liquefy it, those aromatics of higher molecular content must be removed and it must be purified to a very high order. And that is why the rocket fuels are of special class, not like our typical cooking gas type. So, it need to be better reformed. Even the kerosene when you use, it need to be refined to a very high level, so as not to contain aromatics at all. Especially elements like sulfur, etc., could be very dangerous for rocket engines. Okay, there is a question, Mr. Tulja Bhavani asked, sir, is there any use of artificial intelligence in ISRO? Of course, artificial intelligence is everywhere. In your day-to-day life, you are seeing it. In your mobile phones, it is there. So, it has to be there in ISRO, is it not? And ISRO is a top-end institution, and you cannot be keeping ourselves away from use of AI in many applications. I will tell you a little bit about it, AI applications in space. I talked about images that the satellites pick, and from the images you need to understand what this outcome comes. So, we use AI to process the images and then extract features out of it. If you are looking at a image, then there could be roads, trees, buildings, rivers, water, barren lands, agricultural land and crops. And if you are able to identify them and classify them using AI, it is possible. Now, we are having that type of technologies. We also use AI for various other data analytics processes which are there on board. We use natural language processing for voice communication and other systems in our robots. Possibly Vyomitra will be using those AI engines for us to communicate. We use AI for our processing of launch vehicle data for health monitoring and analysis, and autonomy generation in spacecrafts and rockets. And AI is also used for activities like non-destructive evaluation, detection of flaws and defects in our hardwares that we are manufacturing. Like that, AI is used in robotics, vision, processing and things like that. So, there is plenty of activities related to AI, and there are many groups working in ISRO related to AI activity. Okay, let me continue. Mr. Guruvindor asks, sir, which branch of engineering has more utility in ISRO? This is a very typical question that you want to be an engineer and you are wanting to choose whether you want to become a mechanical engineer, electronics engineer, chemical engineer, civil engineer, production engineer, computer science engineer. I can tell you that all of these branches are there in ISRO, but then it happens that aerospace engineering has a dominance, because we deal with space and aerospace. So, aerospace engineers, which of course have their one leg in avionics, one leg in mechanical engineering, and they have more dominance in ISRO. If I look at the total numbers, I see more of mechanical engineers and electronics engineers than other engineers in general. There are of course chemical engineers, computer science engineers, civil engineers, and production people, and many others branches are all there, but they are relatively lesser number. So, a distribution, if you look at the dominance, could be in the electronics and mechanical. The classical engineering streams are top, whereas the newer branches are little lesser at this present. Possibly it could change with the due course of time. Okay, there is a question, Mr. ABM asks updates on Aditya L1. I won't answer here, because these are type of data that is always published whenever we have an update or a new observation in our website. So, I encourage you to look at what are the newest publications, the findings that will come out of Chandrayaan 3, Aditya L1 and other scientific missions that we have on boarded. Please look at it and then update yourself. Okay, there is a question asked, given our advancements in space exploration, why predicting and preventing natural disasters like the earthquakes, the recent mudslides or the floods, etc., why they are unable to be predicted? This is a very serious question and requires a very serious answer. Now, you are asking this question for a space agency, and with the observation that we have, capability that we have, whether predictability is possible. Yes, it is possible to a certain extent, and that is based on the fidelity of the measurements and the amount of ground truth that we are able to collect to correlate with those measurements. So, both in situ measurements as well as space-based measurements are required, and we need to have a modeling to say what this finally will lead to. For example, if a mudslide has to happen, many things have to happen together. For example, the slope of the terrain must be in such a way that it aids that has to happen. The geo nature of that location should be such that it is prone for such thing. The rain intensity should be such high that it is actually triggered, and there are auxiliary activities that takes place around it which should trigger this to happen. And from space, all this data may not be available to you to make a prediction. So, there are space-based observations and ground-based modeling and analysis. Combinedly, only such predictions are possible. I believe that certain level of maturity will reach over a period of time, and what you can do is you can install, which are, for example, an earth-prone, slide-prone area, you can install ground instruments which will detect earth movements, and that sensing data can go to satellite and give you a warning when such a small movements which are beyond thresholds are happening. Some exercise in this regard has been done, and some universities have developed such capabilities, but it is possible for typically for such prone areas to focus on it, and we need to have more investment and more effort towards this in a consistent manner. Definitely space can give you some support, especially with regard to collecting data and giving forewarning, but not into entirety of it cannot be done by space alone. Okay. So, we will look at some more questions with available time. There is a question from Shiva Prasad. He is asking, has NASA has their own international space station, does ISRO plan to have India's international space station? Definitely. I already told you that we are working on a plan to develop Bharatiya Antariksha Station. There was a question itself. So, our space station is named as Bharatiya Antariksha Station, and we will be starting to launch its first module by 2028, building it up for completion of 5 modules by 2035 to have human habitat in it. And there precisely we are looking at it as an experimental platform for us to do microgravity research and work in the platform for a long time. So, there is a question on what are the tips to write a research paper and to find a topic to write. But this is not a question that I can answer in this interaction, because we are not dealing with space alone. It's a research problem, how to attract, etc. are handled in when you go to an institution where you are formally taught on how to conduct research. Research in a classical way needs mentoring. We need people who have already done research and they know how to conduct research. The first and foremost is identifying the right type of problem, and this comes out of your education. After having learned to a certain level, you will be able to familiarize with what is happening in that domain globally, and once you understand what is happening globally, you will understand there are gap areas or new areas that you can explore. And once you understand that, you define a problem that I need to explore and what are the timelines on which that I need to do that, and set out to do it either theoretical, experimental, or a combined way of observing this over a period of time. With the mentorship of a guru, you should be able to conduct those experiments, and after those data comes, make a meaningful analysis of it and come to a conclusion which will be very unique and novel. And this is how a research is actually done. Possibly it requires support of institutions, support of laboratories and infrastructure that are available in either in educational institutions or research establishments. So, research is a very complex process. It requires a certain level of learning over a period of time before you embark upon research. But of course, innovation is entirely different. With your limited knowledge and skill itself, you can modify an existing design and improve it up and bring out great outcome out of it. That can come out of individual initiatives. It does not have to be a conducted classical research activity. Okay, let me continue with some of the questions that are available online. Okay, here is a question which though I do not want to answer this, he talks about the mechanism of aerodynamics used in rockets. There are a lot of things if you want to talk about rockets, how they fly, because aircrafts fly with wings, rockets do not have wings, how they fly. These are fundamental questions I think you should read in textbooks and try to understand. It will be quite difficult for me to answer. But the flight of an aircraft and flight of a rocket are entirely different. and the one which the lift, which is one of the important area capability in an aircraft, is not at all good for rockets. We are worried about having too much of lift, but for stability of a rocket in flight is associated with the lift and drag that are associated with the rocket itself. So rocket is flying defying gravity, whereas aircraft doesn't fly defying gravity. It is only compensated by its own lift. So aerodynamics of rockets are entirely a complex phenomena because it travels through regimes of very subsonic to supersonic and hypersonic regimes. So a same craft going through such long regimes are a very complex system, and we conduct experiments, theoretical and experimental, to understand and model it while it actually flies. You don't see it, all of them, the work of mathematics that goes behind it. There is a question Mr. Ashwin asked, is ISRO planning more launch pads or launch complexes or launch stations in other parts of the country? Yes, of course we are planning. All of you are aware that we have currently only one launch pad or a launch complex at Satish Dhawan Space Center at Sriharikota, and this is very specifically located, strategically located. You know, the Earth is moving towards the turning in such a manner that it is moving from the east to west, and when this movement is taking place, we have the velocity, or rather I said it is from west to east, the rotation. So the sun rises in the east and moves towards the west, and the surface velocity of Earth is always towards the east. So launching a rocket in the eastern direction definitely add a velocity, a component of velocity to the craft which is launched. So putting a rocket launching station on the eastern side, especially for launches which are directed towards eastern direction, is useful. So this is the reason why rocket launch pads are always situated on the eastern side. But when you want to launch to south, like a polar missions or any other direction, putting a launch pad on the western side could be okay. So we have a sounding rocket launch pad at Tumba. Now we are building a new launch pad at Thuthukudi, Kulashekara specifically for launching small rockets like SSLV and commercial rockets of private companies which are coming up if they want to launch towards a polar mission. But if the launch is going to be towards easterly direction or any other inclined orbit, we will have to go back to Sriharikota and launch. There are other launch pads on the northern side, especially for missile launches, etc., but they are not used for launching rockets, because rocket launching also has not just this direction, the safety associated with it. If a rocket is to be launched, at least 10 kilometers around it must be not inhabited, because there is a danger of misdirection and explosion. And also along this path, we have to worry about whether it is flying over land or ocean, what are the nearby areas, if it deviates, whether it will fall on those areas, the shipping traffic and many other aspects, and aircraft traffic, all this must be looked at, and during its flight all these need to be halted, and the economic activity will come to a grinding halt if you have regular launches on such busy areas. So there are many factors which we need to consider while we build launch complexes for rocket launching. Okay, let me go to another question. Mr. Shreyas asks, are there any future opportunities that open up that can be exclusively explore civil engineers with both Earth and space-based project as a multidisciplinary activity? So you are a civil engineer, I believe, and you would like to look at how to contribute in space sector. I'll give you one example. I have an opportunity to meet one of the space agency chief who happened to be a civil engineer and in Europe, and he was from a civil engineering background, but he came to agency and he was working on how to create human habitats in Moon and Mars. So how to use the human regolith, build building blocks, maybe additive manufacturing, and how to create tunnels and civil structures in other planets. So this was one of his topic of research. So you can understand how a civil engineer can contribute. I also remember another civil engineer who worked in ISRO, a leading person who later became a rocket researcher. His background was civil engineering, but later he became an expert in structural engineering, designed a lot of rockets parts, but then later he became an all-in-all, an expert in rocket engineering as well. So civil engineers can definitely contribute, and we do recruit civil engineers specifically in the domains of structural designs and as such areas, but the entrance test possibly could be more dominated by questions from aeronautics and other areas. So, those who are interested to join ISRO, though even with the background of civil engineering, should at least learn a little bit about rocketry, aerodynamics and other domains. Okay, there is a question, Mr. Dev Goyal asked, why don't we use plasma engine for rockets? I don't understand what you mean by a plasma engine. I believe they are electric propulsion engines. For example, an electric thruster is actually working on the principle of plasma. We use a gas, generally an inert gas, xenon, for example, and this is ionized using high magnetic and electric field and converted into a plasma, and this get ejected from the thruster, and hence a propulsion is generated by the movement of this at very high speeds. So, it is essentially a plasma based engine, and such thrusters are already in vogue, but then specifically any other forms of plasma also is possible. We can generate plasma using other methods, for example, RF plasma engine using radio frequency excitation, we can actually generate plasma. And there are electro spray thrusters, though they are not essentially plasma, they are also being used currently. And anything that is heated up to a very high temperature will ultimately become plasma, and depending upon the material of usages, plasma engines can be used, but currently plasma engines cannot produce very high amount of thrust because of the materials, its proximity, the life, etc. are limited by this presence. Okay, so I think we are coming to an end of this session. We will look for any online questions of interest. For example, some of the questions which are appearing are more of repetitive nature, so that's why I am not able to answer them. So, I will go back on some of the list of questions if they are interesting to you. Again, here is a question from Mr. Gayatri. She asked, I have completed my master's degree in botany and I want to work in ISRO. How can I get a job? So, if you are looking at a job in ISRO, I think for botany right now, we do not recruit with masters, but definitely we have people in the botany background, but those vacancies are very less. Generally, we take research scholars in that level of people, especially who are looking at agriculture, who are able to look at remote sensing data related to plants, forest studies, etc. So, those domains, when it comes, those people are recruited, but whenever such an advertisement comes, you can look at it. But in master qualification, masters, we generally don't take. We take people with the PhD background. Okay, there is a question from the name is not very clear to me, but then how does ISRO satellite technologies contribute to addressing pressing global challenges such as climate change, disaster management, agriculture productivity? Very important question. I think this is something that we have been working on all through these years. Let me address each one of them. You know, the sustainable development goals, there are many, and some of them could be addressed through the activities that we work in space, specifically leading to the India meeting those norms. I will tell you a few examples of them. Climate and weather is very, very crucial, and measurement of the essential climate variables through satellites is very important. Out of the 20 odd essential climate variables that we can measure from space, currently we are working on more than 50% of them through space based measurements. We have observations on earth base, ocean and other layers of atmosphere through our InSat class of satellites and our resource and OceanSat class of satellites. And we also help this data to be given to other departments for modeling, creation and prediction. And we also support the climate and weather modeling and analysis, share the data of disasters with other agencies and global effort towards warning. I think all of these are part of the work that we do with the Earth observation system. We also complement these measurements from space using measurements on ground also. We install ground-based observation platform all across the country, especially the flux towers we generally install very at the boundary of the forest and the land to look at the type of emissions that are happening and characterize the ground-based observation with the space-based observations. We also do campaigns across the country, across sometimes into the ocean as well, to grade samples from it and to understand how ocean, atmosphere, earth connection is established through appropriate modeling. So there is a lot of research work happening through various joint work between ISRO and other institutions in this country. Thank you today. I think with this, let me conclude today's program. Wish you all the very best, and I look forward to each one of you to join for the celebration of Space Day this year, National Space Day on 23rd of August. But it's just not the day. I think this is a day of inspiration, and find out where there is a program near your place, either an educational institution or a scientific establishment nearby. They will be conducting this program. Please go there and participate. Create interest in amongst your friends and peers and also your family members. Let's get educated about the work that we are doing in ISRO and in the country to create a technology-friendly nation. And all of you are welcome to know more about space. Log into our ISRO webpage. Ask more questions in the coming edition of this program. Thank you so much.